Hello, Advanced Algebra 2. Welcome to our Concept 21 Notes, Operations with Functions. Now, we are going to make sure that we still focus on some radical functions, but you will see functions from the past as well, quadratic and other polynomial, even some linear. So that we'll start with operations, adding, subtracting, multiplying, dividing, and then we're going to do something called composition of functions in part 2, the part 2 of the notes. So look with me in your notes packet. We're going to be talking about the domain of functions that we combine. So how to determine the domain. You're going to work the problem, and you're going to look at each original function that's involved with the problem. Ask if there are any values that make it undefined or imaginary. So things like having 0 in the denominator and a negative number under an even root. Those are your two concerns. Those limitations, so anyway, if you have values that would do those two things, 0 in the denominator or negative under an even root, then you would need to have limitations in your domain. Also, when you're combining two functions, you look at your answer function and ask the same question, and then you can determine the domain. So first, let's start by just looking at some functions and figuring out if we have any limitations on the domain. So our first f of x equals 3x plus 2. So that's a linear function. There's no variable in the denominator, so no chance to get 0 in the denominator, and we have no even root. So that means that we don't need to introduce any limitation for our domain. So our domain would be all real numbers. Now their second function, g of x equals 2x squared. That's a quadratic function, and if we plugged in values for x, we would not have any way of getting 0 in a denominator or a negative number under an even root, because there's no even root in that function. So our domain would also be all real numbers. Now for h of x, however, we have a variable in the denominator. So if I take that expression, x plus 3, and see what will make it equal 0, it's negative 3. So we have to give the limitation that the domain of h of x cannot equal negative 3. It could equal anything else, but not negative 3. Now let's work these three problems, a, b, and c. So we are adding the two functions, and that's what that notation means. It says take f of x and add g of x. So I'm just going to go grab what f of x equals, which is 3x plus 2, and then add it to g of x. Now I'm just going to clean it up a little bit. I can't combine any like terms. I just put them in standard form. And then I look at my two original functions. They did not have any domain restrictions. And then I look at my final function when I added them, 2x squared plus 3x plus 2, and there are no limitations that I need to talk about there. So the domain of this is all real numbers. Now let's look at b. Notice it tells us the problem is to take h of x and multiply it by g of x. So I go grab h of x, which is negative 4 over x plus 3, and multiply it by 2x squared. So I'm going to multiply my numerators together. Negative 4 times 2x squared gives me negative 8x squared. And then I have an x plus 3 in the denominator. So I need to see what value would make that denominator 0. And of course it's negative 3. So I need to give the domain limitation that x cannot equal negative 3. Now let's look at c. We're going to take what g of x is and subtract f of x. So that would be 2x squared minus, and I need to put this in parentheses, so I subtract all of f of x. So to clean this up, I'm going to distribute that negative. So I end up with a quadratic function. Now my two original domains of g of x and f of x were all real numbers, and so in my resulting function, 2x squared minus 3x minus 2, when I subtracted, I do not need to introduce any limitations for my domain, because there's no chance to get 0 in a denominator or a negative number under an even root. So I would say my domain is all real numbers. All right, now let's jump into example 1. We're going to add two functions. So with these problems, you would just arbitrarily be given two functions. So we have f of x equals 3 times the square root of x, and g of x equals negative 10 times the square root of x. The problem says find f plus g of x. So that notation means I'm just going to take f of x and add g of x. And then I'm going to state the domain, giving any limitations if I need to. I'll do a second part, but I'll come back to that. So let's look at f of x and g of x. F of x does need to have a domain that's limited because I need to keep it positive underneath my square root. So I need to say that all the x's should be greater than or equal to 0. And that's the same for g of x. Now let's work the problem. So f plus g of x. That also means f of x plus g of x. So I'm going to take what f of x is, I'm going to add g of x, and now I'm just going to simplify that. So that would be negative 7 times the square root of x. Now I need to include the domain restriction from the original two functions, and then also my resulting function needs to have that domain restriction, that our x values need to be greater than or equal to 0. Now the second part is evaluate the sum, so f plus g of x, when x equals 4. So I'm going to take f plus g of x and plug in 4. So negative 7 times the square root of 4. So that's negative 7 times positive 2, which is negative 14. All right, so we just did like 3 things there. We added the functions, we stated the final domain, and then we evaluated that sum just given a value of x, and it was arbitrarily x equals 4. Now let's look at example 2. Let's subtract 2 functions. Notice we have 2 new functions. F of x, it's a cubic function, and g of x is also. We're going to subtract them, find f minus g of x, state the domain, and then do some evaluating. First, let's figure out the domain of each of those functions. We do not need to worry about 0 in the denominator or a negative under an even root. So our domain would be all real numbers for f of x. And g of x, also being a cubic function, that is the same. No limitations on what we can plug in for x in our original function. All right, now let's subtract. So we're going to write that notation, f minus g of x. And that means I just take what f of x is, so that's what I'm writing here, minus, and then in a parentheses, x cubed minus 3x squared plus 4x minus 2. Now I need to distribute my negative. So I'm rewriting my first function, and then I'll have negative x cubed plus 3x squared minus 4x plus 2. And then let's just combine our like terms. So we'll end up with 2x cubed plus 1x squared minus 4x plus 7. Now for this one, our domain will also just be all real numbers, because there's no chance for me to get 0 in the denominator or a negative under an even root. All right. Now the last part of this question is to find what the function is when, to evaluate the sum. So we now have that new sum function when x equals negative 2. So we're going to find f minus g, and actually it's not the sum, it was the difference. So we're plugging in negative 2 for x. So we'll get negative 8 times 2, which is negative 16, plus 4, plus 8, plus 7. And that will give us 3. All right, so we did 3 things in this problem as well. We found the domain of the functions, we subtracted the functions, and then evaluated that difference when x equals negative 2. Now let's multiply. So we have f of x equals x squared. Now we have a quadratic function, and g of x equals the square root of x. Notice the notation, f and g are together. You read that as f times g of x. I'm going to state the domain and then evaluate it, just like the other 2 problems. So the domain of a quadratic is all real numbers. There's no limitation, but g of x has a limitation, so we need to keep it positive. So our x values will be those that are greater than or equal to 0. Now let's find f times g of x. So that means I go grab f of x, and I'm going to multiply it by g of x. Now, isn't that awkward, multiplying something squared times a square root? We're just going to leave it like that. And then we are going to give the limitation, since we have a square root in this product, that x needs to be greater than or equal to 0. Let's evaluate this function when x equals 9. So I'm plugging in 9 for my x in both places. So I get 81 times 3, the square root of 9, which is 243. And then finally, our other operation is division. So we're going to divide these new functions. F of x is the linear function 6x, and g of x equals x to the 3/4. So let's determine those domains. F of x, our domain is all real numbers. We don't have any limitations on the linear function. G of x, however, is an even root, so we need to keep it positive. So we need to have our x's being greater than or equal to 0. Now we're going to divide. So f divided by g of x. So normally we have interesting domain things when we divide. Notice that we have x to the first power divided by x to the 3/4 power. So we subtract those and get x to the 1/4. And I just realized that we're going to include our original domain. We also need to make sure that x will not equal 0. Because before we simplified, we had an x expression in the denominator. So what that means is that rather than saying greater than or equal to 0, we just need to change our domain so it's just greater than 0. And that keeps it non-negative. And so positive, right. Okay, now let's evaluate it when, and it's not a sum, so I have that wrong, not a sum. So I'm plugging in 16 where I see my x and my final 6 times x to the 1/4. So this is 6 times 16 to the 1/4 power, 16 to the 1/4 power, that's the 4th root, which is 2. 6 times 2 is 12. All right, that concludes our Concept 21 Part 1 notes, operations with functions. In Part 2, we're going to do composition of functions.